guys, happy Wednesday. I just wanted to document this amazing snow, so I'm doing our intro outside. I love that this is our first day of the school week and it's Wednesday, so we're more than halfway there to surviving another week in 5th grade. We are going to get into lesson 5, you guys, and all we're doing in lesson 5 is applying our understanding of division to word problems. So we're going to absolutely use tape diagrams. Please, 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 please think about what you're starting with and then think about how you're dividing it. Okay, so let's check this out. Okay, so here we are, you guys. Module 4. My hands are freezing from being outside, so my handwriting's a little sloppy. Lesson 5. We are coming for you. We're just going to do some word problems, and it's not going to be a big deal. We are going to RDW our way through these word problems. So let's go ahead and R. A total of 2 yards of fabric is used to make 5 identical pillows. How much fabric is used for each pillow? Okay, please, like we do with any word problems, please make sure that you understand what is going on in this problem before you just start blindly calculating, okay? So let's imagine, first of all, we're gonna have to use our imagination. Let me pull those pillows up again to pretend like these pillows are all the same fabric. So that's your first challenge. So we have 5 pillows. We are going to pretend that 2 yards of fabric will make these 5 identical pillows. You guys see 5 identical pillows, right? Right, Mrs. Calaveras. So we're going to the, Joanne Fabrics. We're going to purchase fabric to make pillows. What we need to know is how much fabric is used for each pillow. So what are we starting with? Well, we're starting with a very crooked line. Let's try that again. We're starting, an even more crooked line. This is hilarious. Why am I, okay, we're going to try it. Oh, yeah. Oh, okay. I'll take that. We're starting with our fabric, and then we're going to make these glorious pillows. How much fabric are we starting with? Well, we're starting with 2 yards of fabric. So here's my tape diagram. The fabric represents 2 yards. We are going to make 1, 2, 3, 4, 5 identical pillows. I know that these don't look identical, but if you squint your eyes, maybe you can pretend. We're going to make 5 pillows, and each of these pillows, you guys, uses the same amount of fabric. So what we need to do is we need to slice our 2 yards of fabric into 5 equal pieces because we're going to make 5 pillows. So we have 2 yards of fabric, and we're going to make 1, 2, 3, 4, 5 pillows out of this fabric. Okay, so our expression here, you guys, is going to be 2 yards divided by 5, or 2 divided by 5. Well, we can do this in a few ways. You guys know that we can rewrite any division expression as a fraction. So 2/5, totally acceptable. Each pillow is going to use 2/5 of a yard, I guess not yards, 2/5 of a yard of fabric. It's pretty straightforward, you guys. Let's go ahead and just do our check step. So if we have 5 pillows and each of them is using 2/5 of a yard, let's make sure that that actually adds up. So that means that we're going to have 5 pillows, each using 2/5 of a yard of fabric. So I'm just going to label that here on our gorgeous photo that I found from the internet. So how many copies of 2/5 do we have? Well, we have 1, 2, 3, 4, 5. Well, how many fifths do we have total? Well, I have 2, 4, 6, 8, 10 fifths used across these 5 pillows. 10 fifths, you guys, equals 10 divided by 5. And my friends, 10 divided by 5 is 2. And that is exactly what we started with. So many different ways we can look at this, but this is a pretty cool problem that really reinforces what we worked on today in class. Let's take a look at another one, guys. Yum! I love when the world of ice cream and math collide, when the worlds of math and ice cream collide. This is my kind of problem. Let's look at this one, you guys. An ice cream shop uses 6 bananas to make 4 identical sundaes, shown here. Don't those look amazing? How many bananas are used in each sundae? Use a tape diagram to show your work. Okay, before we do any of that, let's just think about this. Okay, so for lunch today, I'm going to eat 4 identical ice cream sundaes just in a moment as soon as I'm finished recording this, and I cannot be happier about that. But there are 6 bananas going into these ice cream sundaes, which, so I'm going to draw just some quick bananas. That doesn't seem like a very banana-y yellow. I just need a good banana yellow. Yeah? Does that work? Okay, cool. So we have 1 banana, 2. These are bananas, not moons. If Cal saw this, he would definitely think these were moons. Making my best bananas. Sometimes they're different shapes and sizes. Okay, so I have 6 bananas and 4 ice cream sundaes. Clearly, we have more bananas than ice cream sundaes. So just like kind of thinking about this, using your logic, we're realizing that there's more than 1 banana in each ice cream sundae. Awesome. So what is a tape diagram that can be used to support what's going on in my lunch story today? So what's being divided? Well, what's being divided are the bananas. So I'm going to draw my tape diagram in yellow because, bananas are yellow. How many bananas are we dividing? We are dividing 6 bananas. So my tape diagram represents what we are dividing. We're dividing 6 bananas. Our tape diagram is going to be 1 rectangle that represents 6 bananas. How are we dividing those bananas? Well, we're dividing those bananas equally across 4 ice cream sundaes. Okay, so I have 6 divided evenly across 4 ice cream sundaes. The expression that supports this delicious problem is going to be 6 bananas divided by 4 ice cream sundaes. You guys know that we can rewrite any division problem as a fraction. So 6 divided by 4 is also equal to 6/4. So technically, this is a completely acceptable answer. 6/4 bananas are used for each of my ice cream sundaes. We can also simplify 6/4 into 1 2/4. We can further simplify 1 2/4 into 1 1/2. That's one way to handle this, you guys. Another way to handle this, I'm going to choose brown because that's chocolate sauce. So in class, you guys, during lesson 4, we're doing everything. We're doing every step. Remember, we had our paper divided into columns, and we were doing the problem 1, 2, 3 different ways. We don't have to do it this way in lesson 5, but just know that there's options. Something else that we can do, well, please know that the tape diagram is a must. That's not a choice. You have to make a tape diagram. But then how you choose to solve the problem is totally up to you. So 6 divided by 4, we can also check out 6 divided by 4 just using some old-fashioned long division. So we have 6 divided by 4. How many 4s go into 6? 1. 1 times 4. This is like the most simplistic form of long division you'll see in 5th grade. It's kind of refreshing, isn't it? 1 times 4 is 4. 6 minus 4 is 2. So what we're left with here is 1 2/4. Notice these are the same. So our final answer here, you guys, is 1 2/4. Please, 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 for our secret word, I need you to share how many banana splits is Mrs. Calamares having for lunch. First. Second, when we're solving these problems tomorrow in class, please think about logically what's happening. Kind of draw the story, imagine the story before you just start making calculations. This one is very important because sometimes our brain wants to shift the expression this problem is not about 4 divided by 6. It is not. It's about 6 bananas being shared across 4 ice cream sundaes. That's why I took the time to talk about the problem and draw it, because we were able to see, oh wow, I have more bananas than sundaes, which means I'm going to have more than 1 banana in my ice cream sundae. And in the end, you guys, that was absolutely the case, because we found that 1.5 bananas are going in to each sundae. So I'm off to lunch to eat my ice cream sundaes on this nice snowy day. Keep up the great work, and we will work on this in class on Thursday. Bye for now.